Hello, welcome back to the Introduction to GIS Programming class. Today's lecture, we're going to cover functions and classes. This is very important concept. So previous lecture, we have covered about the data structure, how to do looping, and also control statements. But if you're trying to build some real-world applications, most likely you want to talk about other people's work or use other packages. And it's very important to know how to actually call those functions, how to build on top of other people's work to integrate into your workflow. So functions basically is can find a function to so they can reuse the code block. That way you don't have to write that again and again. So it can simplify your source code. For classes is more like a complex data structure that allows you to build data and also functionality together. So you can have methods, you can have events or attributes associated with each object. So this is the critical part of doing object-oriented language. And some of those functions we have been using it, for example, for the print function, print out anything, right? And you can calculate the sum, you can calculate the mean. So those are some of the functions that has built-in provided by Python. But we can get some custom functions that allows you to reuse the source code. So in this lecture, we're going to cover the various aspects of Python functions and also classes. First, let's talk about the functions. And again, you can download this notebook to your computer. I'll show you here, Visual Studio Code. In order to define a function, you need to use this keyword, def. So basically define a function, and then space. After that, this should be the name of your function. The function name, and then parentheses. So inside, these are called parameters or called arguments, whatever you want to call it. We have two arguments in here, a and b. And so within a function, usually, unless you are just printing out something, then you want to return. The return means when you call this function, you're going to return a value. That way, after you call the function, you can assign value or variable. If you don't have the return function, then the return value will be none. Doesn't values back. Usually, most of the case, you want to have a return here at the end. So after return, everything is the return statements going to be no. So you need to put something, whatever you want to return here, right? In this way, we just adding two numbers together and just return the result. So when we're calling the function, we are calling the name, and then we're going to provide a list of arguments. So in this case, A equal to 5, B equal to 3, and the result will be 8. So one in this one is going to be like this. So when you're calling the function, there are different ways you can call the function. We can also just type A equal to 5, and then B equal to 3 here. And if you run it, same. But anytime if you start providing the keyword, the name of the arguments, the keywords, then the next one you need to do that as well. So you don't do it like this. So when you start providing the keyword arguments, everything else after that needs to do that as well. But I can do it this way. This one is fine. So the first one here I use the default arguments, and then the second one I provide this one. This is okay. Okay, so make sure you know how to call the functions. And if the functions, you can just use the sequence. Don't need to write out the parameter name. Then you'll be just this way. Okay, so it's up to you what you want to do. For this simple case, it's just two parameters. So I can just provide 5 and 3. Then that's it. But for complicated ones, sometimes you have like 10 parameters and they have some default values. Then in that case, you can have like just specify one and then also provide some optional arguments to override the values. But I'll show you some examples later. So this is a very simple function, and then you can change the value, for example, 5, and then you can call the other one maybe 7. One again, you're going to get a different value. So define a function and then calling the functions, make sure your function has a return value. And if you're wondering like how in this code block in here, you can also use the debug function to line by line how it's being executed. So if I hover my mouse here and create a breakpoint, then after that, right click here, this drop down and just debug cell. So we're going to see how this is being executed in sequence. So you define a function, when Python is executing the function, it doesn't run the code within the function until it's being called. So right now, this is highlighted this line. So if I step into, notice that not actually going into this one because it's just reading the definition. As long as the definition is okay, it doesn't really know what is happening inside until you're calling that. Right now, we are on this line and we're trying to call this function. So pay attention. If I run this one, where is it going? Going into this function definition, and this is where it actually executes. So if you have some source code here that's like bad, it doesn't know until it's being executed. So right now, you see here A equal to 5, B 7, and it's going to return. So if I click this one, now it comes back the result equal to 12. This is what is being done, and then after that, I can just figure out the result, number 12. So if you really want to see how it's being executed, welcome to this. And like I said, here I can do like return. Maybe if you have anything wrong in here, it's not going to be able to know. For example, I can say 1A. Even this one here right now, you see it's wrong, but the Python code is not doesn't know that. Debug, right? So okay, now it's pretty intelligent. So that means it can detect this one because the VS code it tells that, but it's not actually executing this line until you call this function. So you might want to be careful about what you put inside function definition. So this is how you define a function and calling the function. And so in this function, we need to provide two parameters. If you don't do that, for example, if I just do this, then it's not going to work because you're missing one argument because that's a require. So add missing one require positional arguments. Why? So in that case, if you want to like provide some default values, you can do it like this way. Argument keyword argument equal to something, then this one is the default value. So if you don't provide it, it's going to use this one, but you can override it. So similarly, if you run this function, take a look, read right Alice, and because the second one we don't provide is going to hello Alice, but if you provide it, it's going to override. So this one will be hi Bob, right? So it's up to you how we want to do it. And again, you can start the debugging and you see how is it running. It's going to going back. So every time, right now we define a function. You run it, it's going to skip it. So it doesn't really run this one until you're calling this function. So first time we are calling this one and see it's going back, print it out. Okay. And this is the first line. Then the second line is going to going back again. Run it, call it, print it out. So all the function is being like this way, being executed multiple times. Depends on how many times that you are calling this. Pay attention to this one. It's have default values. So if you want to have a keyword argument for values, and this is similar to what we have done above. Basically, you define a function and then you calling the function. So this one is multiply. For example, you can provide A and then B, and then you're going to multiply the two, return the product. So 4 multiplied by 5, 20. So 20. I can maybe 4 multiplied by 6 and 24. So this allows you to return the value. And this is just some simple examples. Of course, inside you can do some very complicated stuff. So it doesn't have to be one line. You can have many, many lines of function indented within here. So you can do some very complicated data processing and just return some result. It can be a number, it can be a string. You can also print out something, or you can return a dictionary. This it's unlimited, so you can do whatever you want. What you want to return is decide by yourself. So this is just some simple examples. Next, let's look at some another example related to geospatial. So giving, for example, 2 points, I want you to calculate the great circle distance. Right now, this is a bit hard to see. Go back to the website, the light more here. So we're going to use this one called Haverside function. If you want to learn more, you can go to the Wikipedia, look at the more information. This one basically shows you here, if you have 1 point on the Earth's surface and the other point, you can calculate the basically the shortest distance between these 2 points on the Earth's surface on a sphere. and you can see some of the equations here. It looks quite complicated, but you don't need to look into the details. What we want to do is basically giving you 2 points. Give me the distance. So this is how we define a function. Let me go back to here. I want to show you. For this one, we're going to use the match built-in library from Python. And so we're going to get the radian function, sine, cosine, also square, sqrt, square root, and arctangent. So these are all the functions that we can utilize directly. And we are finding a function called have a sign. Inside here, we have 4 parameters. Okay, latitude 1, longitude 1. So this one is basically the first point. Latitude and longitude, this is the second point, latitude and longitude. Kind of like in here, okay. First 2 represent the latitude and longitude of this point. Second one, the third and 4 represent this point. And so with the giving latitude and longitude, now we can calculate the distance. So this is the radius of the Earth, and you can basically calculate the difference between the latitude, difference between the longitude, and then convert them from degree to radians. After that, we calculate the distance, this one, and at the end, like this. So this is basically the equation we use to calculate the great circle distance. And after that, you can just return that as the distance. So this is basically the function definition. Again, you don't have to worry too much about this one. Just assume that you already know, giving 2 points. And you're going to convert to radians. And then from the radians to calculate the great circle distance. And then return the result. So here we can give you, for example, now we can call in the function. So you can give 2 points, latitude, longitude, and then after that you return the result. So let's run this one. Or need to import. You need to run this one first and import the libraries. Now you should be able to read distance. So you can you're welcome to check out any points. So you can get, for example, I can do 40, okay, and then this one maybe 35, for example. So you should be able to calculate all the distance. Give me 2 points. Of course, you need to get all the points. If you do it like this, it's not going to work because you have 4 required keyword arguments. Right now, you're only providing 2. So you need to follow the instructions. So this is how you can define a function. And this is in geospatial applications, giving 2 points. I get the distance. There are more examples later, but I just want to let you know this is how you can see within here, within a function, we can do all kind of things. You can have very complicated equations, or you can just have one line of code. It's up to you to decide what you want to do. After that, we can call the function without the result. So again, if you don't return the result, so if I comment out this one, control slash, let's see what happens. On this one, and take a look. The unsorted format string has to blah blah this one, because we're trying to print out this one. If I don't print out, it will work just fine. But the problem is that this distance is none. So try to print out this one here. Basically nothing. So is none. You can check it when it's true. The reason for that is that you don't have a return function. So in VS Code here, this is the final result, and you see it's grayed out. That means this variable is not being utilized. So always make sure that you check your function. Most likely, your function need to have a return argument so they can return out a result. Otherwise, you're just doing something and then it's not getting back. So that's not very useful. Let's run this one again. Numbers. This is how you can calculate the great circle distance. 2 points. All right. So next example here is basically we improve this one a little bit because we assume that the Earth's radius is 6,371 kilometers. So if we're trying to calculate the great circle distance, the result you're going to get is also going to be kilometer. But sometimes for some countries, for example, you want to use miles, you want to use other units, you can do that as well. So what we need to do, allow users to customize this one rather than using the kilometer. So again here, right, so the radius 6,371 kilometers. You can provide a different unit. So it's the same thing here. Right now, we rather than hard-coded this variable, then we put this one inside the keyword arguments here. So in that way, it can be customized. So by default, this is basically kilometers, but we see here, we can have kilometer, but you can also have the other one. So this one is miles. Radius of the Earth is approximately 3,958.8 miles. So if you use a different radius, right now this one is miles, then when you call the function, same argument, but you override unit. So basically right now this is a different number. This is going to give you, okay, this miles. So these two, that basically the same distance, different unit. And it's up to you. So you need to decide what you want the user to provide. You don't have the default parameters. You will need to provide. So right now for calling the function for this one here, we don't provide the radius. Then it's going to use the default values and then call the function, calculate the result, and then return it back. Okay. So this is how you can calculate the distance between 2 points. And so the nice thing about the function is that it allows you to do batch processing. So right now we are only doing this just for 2 points. I can provide a bunch of points and then provide a coordinate this. Look at this one, right? Think about here. I'm going to provide you 3 points, and I want you to calculate the great circle distance for the consecutive, the distance between consecutive points. So for example, I want the distance between this point and this point. And also I want the distance between this point and this point. Okay. So right now I have 3 points, but it doesn't matter. You can have 100 points and 10,000 points. It doesn't really matter. So what we are doing here, we define another function, and you give me whatever number of points is the least. Then I can calculate the distance between those consecutive points. So in here, right? So passing the value. Right now, this is the parameter. So previously, all the parameters are just numbers, but you can pass in any. This one is the least. In passing a tuple, you can pass in a dictionary. It can be anything. But within here, we're going to do some data processing. So you give me a list of points, and I'm going to give you a list of distance. So right now, it's empty because we need to loop through the points. So for I in something, so for this is basically the range. Range means it's basically a function. So I will show you here. For I in range, for example, you can just 3 and print out I. So the range is a function that basically give you a sequence of values. The range basically this is the end value. So start and the stop, start, stop, and also the step. So in here we can do, for example, range from 1 to 10, and then step. If you don't provide a step, it's going to be 1 until 9. So provide 2. This is the stop. This one is excluded. So from 1 10, but 10 is not included. So that's why you have 1, 2, 3, blah, blah, something. And you can also have a step. So for example, you provide step 2, that means it's going to be 1, and then you're going to have a step 1, 3, 5, 7, 9, blah, blah. So again, I can have 11, then you're going to be 1, 12, for example, then you have 11. So again, this one is not included. So pay attention to this one. So for the range function, so what we're doing here, so the number of coordinates, for example, it is 3, then 3 minus 1, that's going to be 2. Basically 1, 0, 1. So basically you're going to have 2 points. Because if you have 3 points, you're going to calculate the distance between this one and this one, this one and this one. So you basically only loop it twice rather than 3 times. Otherwise, you'll be out of the index. So what we're doing here is that we're going to loop through the points, and then so for each one we're going to get the index, because I know this index starts from 0. So if you 0 here, that means you're going to get this point, okay? And then 0 plus 1 gives you 1, get this point. And so we're getting these 2 points, and then we apply this Haversine function, get the coordinates, and then calculate the distance. Then we append the distance to this empty disk. After that, going to loop through again to the second one. It's going to get this one, the first point, second point, calculate the distance, append that, and then return the distance. So you can run it. It's pretty quick. So the distance between this one and this one is 8,815. This one and this one is 3,935. And if you're really confused, we can do the debugging. So this can give you a clear understanding how this one is being executed. So again, take a breakpoint here and then debug the cell. See what this one doing here. So we're going to have a batch function, And again, when you step through, it's not doing anything. And after that, it's going to come back to here. So we're going to have 3 points. And when it's calling the base function, so come here. Right now, the distance empty because I haven't calculated yet. On this one, so it's going to loop through, right? So right now I is 0, and the coordinates, right? It's going to get, pay attention. Right now on the left side, it doesn't have yet latitude 1, longitude 1, so 35, 139, and 1 again to get the second one here. So now we have latitude 1, latitude, longitude 1, longitude 2, and it's going to calculate the distance. So if I run this one, pay attention, where is it going? Coming back to here, and then it's going to calculate the function and give you the table sign, basically the distance, right? So one by one, after that, it's going to come back. So now we have the first distance, 8,815. Then it's going to append this one to this empty list. Again, right now, here it's empty. Run it. Now we have 1. So we finished the first one, and then it's going to calculate the second one, and going to get the values, calculate the distance. So if you, sometimes if the function is like very long, you can actually skip that. So on this one, you can step over, and you need to do the continue. If you want to continue, it's going to finish everything. Then it's going to come back this one. Now you have all the distance being calculated with Haversine function. So you can look apply this one to an unlimited number of points. This is the power of using programming, is that it allows you to create functions and you can do batch processing. Within the function, you can call another function. Yeah, right. This function is calling the other function. This is very common because if you build on top of other people's work, you're going to import the packages and you're going to call the function of those packages and have your custom function. So we'll talk about more later in this course about how to do on top of other packages, calling the function, calling the classes, like that. So that's about the functions. And so for functions, you can, in some of this example here, we provide the keyword arguments. If you sometimes don't know, like want to have a variable argument, so basically you don't know how many arguments people are going to provide, you can have a star sign here. The star sign means here you can provide an unknown number of values, and it's going to grab all of them. So in this case, we are creating a function called average. And within here, we have a star, the number. So that means you can provide any numbers. So you can provide 2, you can provide 3, you can provide 4. And when you are calling the function, take a look at this one. You have the parentheses. You just provide 3 numbers, calculate the sum, and then divide it by the number of points, and then give you the average. I can provide 4 points. I can provide 5, 6, 7, unlimited. So this can be useful if you want to design a function that you don't know how many parameters, how many values that the user provide, then you have this one at the beginning. So if you don't have this, that means you only have one number. You only provide one. If I try to run into errors, I'm going to say the function only takes one positional arguments, but 3 were given. Right? So you're calling this function, you provide 3, and this function doesn't allow you to do. So if this is what you want, always make sure that you put a star at the beginning, then you calculate it. Besides the star means you can only provide the values, but you can not provide the keyword arguments. What does this mean is that if user want to provide, for example, name equal to something, population equal to something, it's not allowed. So you can only provide values. You cannot provide the name, basically the keyword arguments. And this is also very common in all kind of Python packages. Sometimes for some function, it allows you to provide anything. So here we have a function called describe points, and the first 2 are required. After that, this is optional. But what we mean by optional is that you can provide a keyword argument like this, right? So the name in here is not provided, but you can provide a name, also the value, a name, and a value. And it can be anything. And within the source code here, so we're going to print out, for example, the point at these coordinates, and it's going because this one is actually a dictionary. So you can think about If you don't provide anything, it's an empty dictionary, like empty dictionary like this, so curly brackets. And so when you're trying to get the items, doesn't exist, it's empty, so it's anything. But it's going to be, so you provide something like this, side looking like this, would be name and then colon and Tokyo YO. So basically, when you provide, for example, when you're calling this function and then provide something like this, oops. So this keyword argument basically looks like this. So this is why when we are calling the function within this one, we are looping through the keyword arguments. You're going to separate by comma and then print out the key, print out the value, print out the key, print out the value. And it depends on how many you have, so you can have unlimited, right? So name, Tokyo, population, and I can have another one. I can have another one, for example, country equal to Japan. Okay. I can have another one, maybe continent equal to Asia. So you can provide unlimited numbers. So this is super useful. And later on, when we use some of those geospatial packages, we're going to use this one quite a lot. So make sure you understand this one, KWARGS, and you have 2 stars. So that means you can have a keyword argument, a value. This is called keyword argument. And super common. So make sure that you understand this one. When you define a function, you want to provide some additional arguments with name, value. This is what you can do. Right, so this is about functions. Again, you want to use function a lot. Use geospatial packages. Next one we're going to cover is called classes. This is also super important. So basically allows you to create different data structure, and you can provide which and can create object based on classes, and each object can have attributes and also have methods. And this is the whole point of doing object-oriented programming, that you can create an object, attribute, methods. So here is a simple example. You're creating a class. So a class, the keyword class something, and the naming convention is that for class we're going to use title case. Different from the functions. For example, we all use so-called lowercase and also snake case. That means you have underscore and all lowercase. But for class, we usually have uppercase. So for example, later when we do leaf map, you use class map uppercase M. So for point here, and then within here we have colon. Within the class, usually for each class, you're going to have this function. This is more like the default one, trying to create an object. So initialize underscore underscore init underscore underscore, and then within here you can provide the function. So for all the methods within the class, you're going to have this one, self, at the beginning. So for example, self, some self, comma, and then after that you can have this. This is basically something you need to put if you want to access this function within this map class. So it's basically associate the class or the attribute with this class. So right now this is an abstraction. So basically it's just like you can think about it's a template, create a point. And then so in order to create a point, you need to provide the latitude and the longitude. The self basically is a pointer to this object, this class itself. So if you provide the latitude, then I'm going to assign the latitude. This basically allows you to be accessed outside this uh, class definition. If you attribute latitude, it's going to assign the latitude to this attribute, this class. And if you give me a longitude, I'm going to assign the longitude. And also, I'm going to give a name. If you give a name, it's assign name to this. So the name here by default is none. You can provide it. If you don't provide, by default it's none. And we also have the underscore underscore str. So this one is also kind of um, a method that you can use to print out something. So if you have this one underscore, so pay attention here, there's 2 underscore, 1 underscore. And here it's going to return. So basically return a string. Give it a name. If the name is not none, going to use the name. Otherwise, going to use the point. And you're going to print out latitude and the longitude. Look at this one here. Once we have the class, then we can call this class to create, basically initialize. When your initialization, you need to provide latitude, longitude. And you will notice in here, you don't need to provide self. Self is basically something related to the class itself. So this one is ignore it. So this class basically, when you are creating this object, you need to provide these 3 parameters. The last one is optional. Don't provide, it's going to none. And take a look. So we create this object and providing these 3 parameters. Then we can print out this object. So when you're printing out this object, it's going to be looking to this function underscore underscore. Again, if you don't really know, you can always do the debugging. You can loop through it to see how is this one executing. I'm going to run the first one and skip, right? So this is the class. We'll read the function definition. So just when you are executing this, it's just going to look in definition. Doesn't actually run the code inside until you create the object. So run this one again and then come here. So this is where right now it's actually really creating this object. So we have the latitude here, we have the longitude here, and we also have the name here. Right now, this self here is pretty much empty. There's nothing in here. So if I run again, see the first line, we have the latitude. It's going to assign. So right now, this object has a latitude attribute. Run again, it's going to have the longitude attribute. For the name, it's going to be Tokyo. Look at this one. Now, this point, this is the point right now we created. So this point becomes an object. This object has these 3 attributes. After that, we can print it out. So run again. Going to print. So when it's printed out, it's going to look inside your function class. See if you have this one, the s underscore underscore str double underscore, and it's going to run this one. So see, so now we have this point, and you can change it. For example, I can say New York. Example, I can maybe 3918 something like this. You know, New York. Actually, this line. You don't provide anything. By default, is going to be none. If this none, you're going to actually use this value. So without point. Okay. So this is a very simple class. Okay, class, and then title case. Within this class, usually minimum, you need to have the underscore underscore in this way you can create the object and you can assign the attribute, and you can also make sure that this attribute is accessible. So again, so if I run this one, run this line, now this point is a class. So I can actually, it is its own object. When you create the object, I can say point dot latitude, right? And then point dot longitude. And you can create multiple points. So right now this is point 1, right? I can have another point 2. So I can point 2 equal to point here. Okay, cool. And I can print out point 2. You need to print out. Okay, so here's the way call the function. So again, class is just like kind of like a template that allows you to create all kind of objects. So you can create different classes. For example, I can create a class called student, right? And then I can give you a name, give you a major, give you something else. And so this is very flexible. So this is basically the blueprint of creating objects. We're going to talk about this more when we create a map. So for example, I can right now show you like import leaf map. We have already installed. After that, we're going to call the functions. For example, map equal to leaf map dot map here. In this case, map is a class. And when we call this class initialize, now this becomes an object. So this object is an assigned to a variable. On it. Oops. Huh. I need to fix it later. Or I can do it like this. Holding map, go to leaf map. Once to work. Right. So I have a map class in here. And then we create a variable name, and then after that we can access all the information. So type m dot something. So m right now is an object. So this m has all kind of things. For example, all the functions available here provided by. Again, we cover this one in the next couple weeks, but class is a very important concept. Make sure that you understand that. And so within the function, within the class, you can add methods. This one is the default one when you create objects, but you can also have other functions. So this is basically a combination of class and functions. For this function, we can inside the class we can have a function called distance too. So we have a class called point, and when you uh, have an object, you can call this function and you can provide another point. Then in here again, we use the sign function to calculate the distance, great circle distance between different points. So look at this example, right? So again, forget about this one right now. So we are creating a point, initialize a point, provide the latitude, longitude, and the name. Second, also provide create another point with different latitude, longitude, and also the name. After that, we can calculate the distance. Look at this one, 0.1 dot distance. Maybe let me run this one first, and then I can show you. This one here looks a little bit complicated, but what it's essentially doing is once you have object, this object has this class measures. So I can do 0.1 dot distance. See here, right? So now this is measures, and this measures inside here can provide another point because we have 0.1, 0.2, right? 0.2, and then run it. You can calculate this. This is what this one is out. So you can create multiple objects and you can calculate all kind of distance. Or I can also do 0.2 distance to 0.1. You should get the same result because this is the same point. But my point here is that you can add as many functions as you want inside here. Or I can also do, for example, I can calculate the midpoint. That's basically I want to calculate, give you 2 points. I want to figure out the mid latitude and basically the center point of these two points. So I can create another function called df, and then maybe midpoints. Okay, pretty intelligence. So in here we create a you can provide another point, and then it's going to return another point. So this point is going to use the self latitude. So self basically means you're doing here point dot something. So this will be the self. This will be the other point, and it's going to self because it has the latitude attribute. We're going to get the latitude, and then the other one get the latitude. The other one divided by 2, and similarly longitude. The other point longitude divided by 2, and out. So let's run this one again. Now we can take a look. So we can do 0.1 dot hit point 0.2. Run it. Oh, it becomes another point. So you need to basically assign this one to a value. For example, mid point equal to, and then run this one. So this becomes a midpoint, and then the midpoint I can do the, for example, the latitude, right? Then longitude. All right. So this is how you can do that. The reason we didn't have because we didn't have the this underscore this function. This one is not printed out. So copy this one, then come back to here. Need to print out the result. This can be helpful. What we need to do here, read one function. Then when you calculate the midpoint, it's going to find this one. Then we can call the print function. Print midpoint. Then you should have, okay, it returns another point. So this is the latitude, this is the longitude between these 2 points, right? 34, 35, so it's 4.87. Negative, positive, negative, then that was 10. So this is how you can define a class. Within there, you can have attributes. So this basically is just attribute, and this will be just a function. So I can create, for example, a class called person, and within here I can have a person, for example, name, height, weight, and maybe hair color, whatever, right? Measure your address or something like that. I can also define a function. So this is basically actions, like actions. The person can walk, can run, and you can study, you can do all kind of things. This is how within a class you can do all kind of things. And the class is just a blueprint, just a template. It doesn't exist until you call the class and you initialize, then it becomes an object. So that object is going to inherit all the things that this one is here. And you can also provide default values. So for example, if the class like latitude, longitude, if you don't provide, I can have unnamed rather than require. This is pretty much similar to the function that we covered earlier. So you can also have, for example, like this keyword arguments. So this is also super common. I can provide as many as I want, right? So again, I'm going to make this one. Here I can create another point. Point 3 equal to point, and right. So I can have a latitude, longitude, give a name, and I can provide also unlimited stuff on this. I'm gonna have a point. So right now the point I'm gonna have. Of course, these are not accessible because within the function we didn't really anything in here. But if you want to, I can say for key or in something state attribute. This way, these uh few arguments will become an attribute of this one. And on this one. So now I can access it. The point 3 dot. And so if you scroll down here, we have a country, we have a name, we have the latitude, we have the longitude, right? So I can get the population. So this is how you can define a class with unknown keyword argument. So you can provide as names as you want. If this is something you want, you actually, and this is pretty common in many geospatial packages, Windows objects that allows you to provide a variable number of arguments. Last example, allow you, for example, to extend. For example, we can create a class called route. Within here, I can point. So pay attention, right? So this is the points that we can find. It's the point class coming from here. So we can use that as an input to another class. So when we're initializing the points, we're going to get the points, and then we can calculate the total distance. So we can have basically a number of points, 0.1 and 0.2. Then within here, we can calculate the total distance. Again, the total distance is going to get all the points because when we create this one, we're going to provide the points, and the point is going to assign to this class. And this class, for example, save the points is going to be accessible within different functions because it's an attribute. So we can have a class, and then we define, okay, the total distance is 0. Then we'll loop through the points. So for this one, because we have only 2 points, we're going to basically get calculate the distance from the first point to the second point, and it's done. But you can have multiple points. This is more like a more complicated example of combining different classes, different functions, and then within there you can have a function. And so I can have, for example, calculate the total distance of 2 points, 3 points. It doesn't matter. So this is going to loop through all the points, and then going to accumulate all the distance and log something distance to. This is the function that we have defined earlier. Here, distance. This one here, and then calculate the function on it, allow you to calculate it. The goal here is that you can have more points, right? So I can have maybe 0.3 equal to blah blah, okay, 0.4 equal to like this, and I can provide here 0.3, 0.4, and run it. This is basically within here the looping, dealing with doesn't matter how many points you have. You have 4 points, you're going to loop through this 3 times, right? First point to the second point to the third point, and then the third point to the fourth point. And you just add them all up together. Up with the and for beginners, this might take some time for you to digest. But again, you can use the debugging. You can use ChatGPT, whatever, trying to step by step. This can get quite complicated. Right now, it's still pretty simple functions. Have 1 to 2 methods. But if you go to, for example, to look at some of those source code, I can show you here. If you go to maybe leaf map, for example, and it's all about classes and functions. If you go to leaf map, to show you here, if you go to the source code map, and then if you click any of those module, for example, leaf, So inside here, you're going to see our import. This is where it's the class. So you can actually inherit a class from the other class. We haven't covered this one, but we will talk about more later about the semester. So within here, right? So see this one, you have an underscore underscore. Then you can provide an available number of keyword arguments. Side here is going to do something assigned to attribute, blah blah. After it, you can have all kind of functions. Here, add function, add methods, zoom, set center, blah blah. There are tons of methods that have been implemented for this map class. So it can get very, very long. This can get thousands of lines of code. We are only actually doing a couple of lines of code. So again, try out this one. And also, may look at the documentation here. Might be easier to see, for example, API ribbons, if map, and then look at here. This is the map class. This map class has all these methods that I have implemented class. So you can have like also how many? Like hundreds of those methods for a class. And it can get quite overwhelming, but right now we only have one class, one method, 1 to 2 methods. This one is whenever you create an object, this is the one that's executed by default. It's always being executed by default. So you make sure that you have this underscore underscore. Also have some exercising here. You're welcome to try it out when time. Okay, so that's all for this lecture. I will see you in the next one. Take care. Bye bye.